Okay, good morning everyone. My name is Michael Ford. I work with Aegis software. But today we're going to be talking about some of the interesting, cool technology we've got just over here behind me. You may not realize this, but has anybody heard of IPC CFX or the Hermes standard? Yeah, a few people. Well, you know, this is kind of a historic event because this is the world's first actual demonstration using live manufacturing of the CFX and Hermes standards. So this is the first time where data from a shop floor is being sent into a cloud for everybody then to look at and understand how that data is used in a smart factory or Industry 4.0. And that's what we're going to be talking about today. So these are the companies who have got together to make this all happen. So we are very grateful to each of these. We'll be going through what they've been contributing in a few minutes. But today we're going to start talking, first of all, to understand what is Industry 4.0, because I'm sure everybody here has a different understanding of what it is, coming from a different kind of angle. We'll have a look at the technology on show, especially with the manufacturing demo itself, what the participants have kind of brought to the party, what we can see later. And then seeing from that, what are the real values that we get from that data with Industry 4.0? So that's the agenda for today. So first of all, let's have a look at the real Industry 4.0. Now I say real because Industry 4.0 is business as well as technical as well as people, and of course not without its challenges. So we'll be having a look at some of these. Now, the business case for Industry 4.0, it's not new. This is not something that the German government suddenly invented because they felt like it. Actually, it was a trend that's been happening in manufacturing since I've been involved, and that's like 25, 30 years now. We always want to have the smallest investment in the distribution chain. Do you know that products that are made in China, it costs more to ship them from China than it does to actually manufacture them? So when we are buying devices around the world here that are made in China, most of the money that we are paying for those devices is a waste, because we're spending money on energy moving those products from China to the UK, consuming resources, polluting the atmosphere. I mean, we're basically really in a loss situation. If only we could make those products in the UK and be able to ship them directly to customers. That would be a way of reducing that cost in the distribution chain. Guess what? If we reduce that cost of distribution, we can use that money to invest in automation, which means new machines, but also in Industry 4.0 software that controls the area above the machines. So that's how Industry 4.0 is going to pay for itself. We are going to have factories locally which are more flexible, which are going to be capable of delivering product almost made on demand, but at a productivity that matches what we were used to in mass production, if we can remember that far back. So this is interesting, but then when you put on the fact of the political problems that are going on right now, I should say political opportunities maybe, depending on who you are, but with Brexit, with Donald Trump, if I should mention that name, I mean, there are a lot of things changing in the world right now, where it may be more and more difficult to do business across borders because of different taxes and tariffs, but also incentives from government to be able to bring manufacturing home. So now is the time when, you know, we heard Donald Trump actually say to Apple, now Apple's an interesting case because they claim that only 1% of the price we pay for an iPhone is actually the cost of manufacturing. 1%. So where's the other 99% go? It's like 40% maybe in the pocket, some of it in transportation, of course a lot of materials. But Donald Trump went up to Apple a couple of weeks ago and said, guys, you need to make your products in the USA. Can you imagine what would happen if a contract manufacturer, some EMS company in the US, had a telephone call or a knock on the door saying, okay, we're Apple and we'd love to have you build our product? Imagine, are you prepared for that? Are people ready for that? You know, this kind of thing seems extreme. unlikely perhaps, but there are many, many, many other companies than Apple, much smaller companies, who are interested in doing this. And we need to be prepared as an industry for when that happens. So the ones who are prepared, the ones who have the tools, the ones who have the environment for digital manufacturing, Industry 4.0, they are the ones who are more likely to be able to take advantage of these opportunities. So no matter how the votes go, or taxes or tariffs, it honestly doesn't matter. We need to be prepared no matter what. So of course it means that we're going to be potentially building a higher mix of products, maybe smaller batch quantities. Maybe we'll have some kind of investment in further automation. Already this story has affected the industry. If you're walking around the show here, there are a lot of machine vendors with a lot of nice machines. But are you going to buy one that does not have an Industry 4.0 story? No. You need to buy stuff that's going to be future-proof. And so everybody's come along with a story about Industry 4.0 because they want to continue their business. We've seen a couple of manufacturers, the big guys, Jabil, Foxconn, these kind of people, they have created their own Industry 4.0 factories at a cost of $1 million or $2 million per site. That's not exactly going to be affordable by most people. I don't think anybody here has that kind of budget for automation. So we've got to find a solution that's actually a lot more cost effective, that's available to everyone, not just the rich. So actually what is Industry 4.0? It's kind of digitalization across automated processes. I mean, our automated processes are our SMT machines, our reflow ovens, our AOI machines. They're already automated and they have been for many years. Industry 4.0 is the digitalization across those processes. Because we need to manage those processes to get them to do what we need to do for the customer today. In the past, we would have a long-term schedule, 6 months sales forecast converted into ERP, into a factory plan, and the factory would simply execute whatever it had been told to do. It's a great time, you didn't really have any immediate problems other than quality. Everything was quality driven in those days. Now, that situation's gone completely. ERP is no longer able to schedule a factory. If you go into any factory pretty much these days, the main planning tool is Excel. It's the guys on the shop floor who decide what to do because they are the only ones who actually see what the machines are doing. And this is the core of where Industry 4.0 came from, being able to see and understand what the machines are doing and then be able to plan what we're going to execute in terms of work orders, deliver in terms of materials, and even plan from hour to hour, day to day, as customers change their mind. So these kind of decisions are being taken from people and becoming more automated. Now, with people, at least in the factory I used to work in, if we wanted to make a change, we had a telephone call, we had a series of emails, had a couple of meetings, had to meet with the materials guys, the quality guys, the manufacturing guys, the customer guys. Eventually, people would come along with a decision. Okay, we're going to change manufacturing a certain way, and everybody's good with it. That decision took days. Now in Industry 4.0, we need to make the similar kind of decision almost in seconds. And so what we need to do is to bring the necessary information in order to make the decision, to know how to satisfy the changing customer need without introducing a risk to manufacturing not being able to fulfill other customer orders. So bringing that information digitally into a computer, I mean, later, maybe this guy will be making the decisions in manufacturing. I don't know, in 5 years, 10 years' time. Today, it is the guy we've got in manufacturing with the experience and the skill who can make the best decision, but only if it's based on good information. So that's how we start to evolve down the path of Industry 4.0. The problem, of course, that we have is that data in manufacturing now is, how do I say in a way not to upset people, but it's not been good. You know, we've not had consistent information from different machine vendors for even the same information. It's all been in proprietary formats. Sometimes it works, Sometimes things change, even improve, but it causes things to fail. So we've had a situation where digital information in the factory has not been trustworthy. And that's been a major problem, at least for implementing Industry 4.0. And then, of course, we have to think about the humans involved in Industry 4.0. Because, I know we have an idea of digital factories being all machines and computers. But actually, as we learned from Mercedes-Benz and their S-Class line, where they took out all of the robots and replaced them with people quite recently, operators are our most flexible asset. In most manufacturing, we want to continue using them. And how do we transition from an operator being dedicated to a particular job to actually being able to perform many different tasks around the factory? So instead of being specialist in one thing, they have enough knowledge about many things, and then they're guided with these glasses, where information is streamed to them in real time, giving them information about what to do and how to do it. The demo, the stuff that I've seen with this, I could be wearing the glasses, and I could assemble pretty much anything just following those instructions. And I'm not an experienced manufacturing guy. But if we can get to that level of guidance to be able to enable people to be that flexible. So for example, maybe at first I'm putting parts in a board, then I'm doing a quality check, maybe then a materials movement, then maybe, I'm doing some other job, maintenance on the machine even. I can use my time productively 100% of the time. And this has not been achievable without that. So we talked about the decision makers. They're also human for the time being. And of course the business management, who will always be human, I expect, where we want to see a net result for our business in terms of profit. But if we think about Industry 4.0 today, the idea seems good. The actual execution seems quite difficult and expensive. For manufacturers, for machine vendors as well, machine manufacturers, they're making 30, 40 different interfaces for different customers. It's becoming very, very expensive for them. For IT teams and solution providers like ourselves, again, a lot of the effort goes to creating machine interfaces. If I were to go out and try and sell a machine interface, people wouldn't want to pay for it because they expect it as a given. It's not something that they would expect to have developed. So it's not adding value. The rest of the software, the stuff that does something, people will pay for because it delivers value. The machine interface itself should be just a part of the solution. So right now, Industry 4.0, to be honest, is looking quite bleak. We don't have the tools to go forward. And so that's where IPC with CFX have stepped in to fill that gap. So we look at now the technology driving Industry 4.0, and we start with the Connected Factory Exchange. We kind of thought, wouldn't it be really cool if every machine had the same infrastructure for communication? Wouldn't it be really nice if you could go around this show, choose the best machine for the job, put it into your production line, and it works? It just works. It connects to the existing network. All of the data you need comes out. No special interfaces, no customization. It just plugs in and it works. That was the goal for CFX. We wanted to be able to link machines together, systems, even kind of interaction with humans, transactional kind of jobs. Of course, being IPC, it's a completely consensus-based standard, so there is no licensing or contracts or dependencies. And we even have put in a software development kit so that people who would like to implement Connected Factory Exchange can simply drop that software library, I guess, into existing software and have it speak CFX very, very quickly. So by doing this, it means that Industry 4.0, at least the framework for solutions, becomes almost free. There is no $1 million price tag or $2 million price tag for creating Industry 4.0 in any factory anymore. Now, what we actually mean by a standard and what is different about CFX, I like to equate as a telephone. Now, we all have mobile phones, yes? Probably some from fruit-based suppliers, maybe some from suppliers from far, far away. But you know what? They're all standard. It doesn't matter which handset you have. You call each other, you don't even realize it's different. And also, another part of the standard is the signal that connects us all around the world. It's completely standard. I could be calling my friend in Japan, and his phone works completely, perfectly. And so it's a standard network, standard handset. So I call him on my phone, I say, "Konnichiwa, genki desu ka? Shigoto wa dou desu ka?" Now that's Japanese, because he speaks Japanese. I speak Japanese. But do you guys speak Japanese? Probably not. So the important thing here is not just the phone. It's the language which is being spoken on the phone. And this is why within CFX, actually I'd say 90% of our work has been creating the language which is spoken between the machines. So there are 3,000 languages being spoken by humans on this planet right now. I hope that in the future there is only one language for machines, at least in assembly manufacturing, and that is CFX. So this is what we've defined, this is what we've created to enable this plug-and-play environment. The Hermes standard is another kind of layer of automation. So I think in the past we have known what SMEMA is about. Since, I don't know, it was the 1980s or something, SMEMA. It was quite a long time since that. But it was a cool way where you can exchange the signals, the very basic signals on a production line to make boards flow. That's how it started. But you know what? That's like many years old now. And surely it's time to make something a little bit more interesting. So the Hermes standard replaces SMEMA. But it replaces it, obviously it does everything SMEMA can do, but it also introduces an opportunity to exchange data directly up the line, or let's say along the line. So that, for example, today if you're doing exact traceability, you have a barcode reader on the first machine and the data is collected. You have a barcode reader on the second machine, the data is collected, and the third and the fourth. With Hermes, no. The idea of the board that you're making passes down the line automatically. And in the future, lots of other data about the product will pass down the line automatically. So it means that the line becomes basically a work cell, a complete digital work cell, which is being managed through the Hermes. So we're avoiding the duplicate hardware. We're able to do some really cool things as we pass this information down the line, such as the one-piece production, the progressive changeovers. And this is completely complementary to CFX. So if you like, Hermes works horizontally down the line, and then CFX is taking the data vertically away from the line. So there's no overlap, it's purely complementary, and these two standards work together, and they are both now within the IPC environment. So, yeah, as we said, SMEMA, it's been extremely successful. It's been powering our machines in our factories for many, many years. But, it's basically time to move on. And it works with a very modern interface, the Ethernet connection, so life becomes a lot simpler than before. Now, what have we actually created then? We've talked a little bit about Industry 4.0, CFX, and Hermes, but what does it really look like? Now, this is a kind of representation of our factory. We've got your machines here. We've got the Hermes standard working on the SMT line. This is what we will show over there soon. But also CFX looks at the manual workstations. It's gathering data from assembly and even the functional test. For example, a contract manufacturer or OEM, they have a factory with their own machines. Are these machines connected to any MES system today? No, because they're proprietary machines. But you drop the CFX SDK in there and they become part of the network. And everything works together. So exchanging data across the lines, machine to machine, feedback, closed loop, whatever, that is all supported. But guess what? That data becomes available to the next layer, which is the factory solution, the digitalization of the factory itself. So all of your favorite kind of operations, like lean materials, process engineering, production control, documentation, dashboards, all of this can now be generated using the CFX feed. But also, information on the factory about materials, for example, is then also available back down to the machine level. So machines get a heads up of what materials are coming, what products are coming, what schedules are coming. So there's this interaction between these two levels, such that each of the machine providers, each of the solution providers, they can all independently offer Industry 4.0 solutions that all work together, because the common framework is CFX and Hermes. Even then, going up to enterprise systems with business intelligence, ERP, PLM, all of those systems are also then fed data from both the factory and also from the machines. And so, for example, with ERP and the MRP, we have times now where we have material shortages. Okay, we can't solve the external shortages, but a lot of the problems start internally, because we don't understand what materials we actually have. ERP is not very good at keeping track of its materials. As soon as they get out the warehouse, they don't, ERP doesn't know if they're on a circuit board, or if they're stored somewhere, are they on a machine, are they used or spoiled, just doesn't know. Do a stock check and find out how many materials you find that you didn't know you had. And so having the information directly from the machines in terms of consumption and spoilage drives a perfect digital supply chain. So you don't only get traceability, but you have accountability for every material in the factory. So when you need to make that decision, can I make a product for a customer? The answer will depend on what materials are available, and you know without doubt what and where those materials are. All again uses CFX. So these are just a couple of small examples about how CFX can revolutionize the way the factory is working. So when we look at Industry 4.0 now, with the addition of CFX and Hermes, it's an entirely different story. It's no longer difficult and expensive. Manufacturers have all of their equipment which is now compatible. It's using one interface. Machine vendors, they only need to support one interface. I mean, one interface is CFX and also Hermes, of course. But it's just one instead of 30 or 40 that they used to. And for IT teams within factories, again, they don't need to worry about what machines they're buying. They just have one interface to integrate all of their internal systems as well as internal machines. And even for us as MES providers, I hope that we are now developing the last interface that we'll ever need to make. So what are we seeing here at the actual demo? It's really quite simple. We have some machines from these leading manufacturers. They are connected through CFX and Hermes. We have data coming from the machines into a web server in the cloud that we are providing. Now basically, the reason we did this is we wanted everybody to have access to the data that's been created. Actually, you don't even need to be here at the show. It's in the cloud. People on the other side of the planet are watching this right now, and they're seeing what's happening on these machines. If you go with your mobile phone and you go to connectedfactoryexchange.com, or you read the QR code that we'll have on the screen down there, it'll take you directly so that you can monitor the live data coming out of these machines. So what kind of data? For example, the ASM machine is going to tell you, I mean, obviously the machine is running or it's not running and what state it's in, but also it's going to tell you what placements have been made. So all of the information about placements is coming and shared into the web. From the inspection machines, from the screen printer, of course, and the placement, that kind of information about what has been done to a product. From the inspection side for solder paste and AOI, then we have information about, okay, what has been measured about that board. And so we can imagine that that data is going to be compared. How did production actually perform? Now we have, in real time, understanding of exactly what was done and exactly what was measured. Heller at the end, this is an example of the same data, it's CFX data, but this time it's for traceability, so that you can see the conditions in the oven as the product passed through. So CFX is comprehensively across the board providing exact traceability for all of your processes. Wow, I said this thing was quite inexpensive, but I didn't think traceability is now free. It's free. You get all of that information that you need as part of running your smart factory. That's a critical thing. Mentioned the SDK. This is available right now. The standard is about to be published in its first revision, but the software development kit is available for people to start to integrate. Who would want to do this? Machine vendors, of course. We have 50 or 60 machine vendors already in process. Manufacturers who might want to gather the data into their MES systems within their own site. Solution providers like ourselves, we're already taking that data and connecting it with our existing functions. So this is the key that makes it happen instead of in months of development and many, many business trips and lots of arguments over the phone about how these things are going to work, how the interface is going to work. I think without exception, all of the CFX implementations done so far were tested online. There were no business trips, there were no difficult conversations, everything was done and tested online. So it's a whole new generation of interface. These are the kind of messages that we see coming out. You don't need to read all of those. But we can see that we have different kinds of information, different kinds of messages, what happens to a production unit, materials placed, things done to it, even testing, for example. We then have resource performance, how well is the machine running, any times the machine has stopped, we need productivity, first pass yield. Materials, consumption, spoilage, traceability, and also information system, which is data from sensors, it could be work orders and schedules. So the whole operation of the factory is encoded into these different colored topics, and these different topics have different messages, so that you can subscribe to whatever kinds of messages you'd like. In order, for example, you might have a lean materials system. You look at the green ones. You might have a scheduling system. Okay, I want to look at the red ones and the purple ones. So it's very, very easy just to piece together the exact CFX flavor that you want. So the participants in today's event, first of all, ASM on the printer and the SciPlace placement. ASM have been a leading company in software for many, many years, of course, and personally I think they are driving the industry forward in terms of use of data. It's been great to be working with these guys. They are also one of the leading participants in the Hermes standard. So one of those companies that is driving the industry forward, making the digital factory of the future a reality today. This is what it's all about, and this is ASM's commitment to these standards. For the inspection, for solder paste and AOI, we have Ko Young. I remember presenting about 3 years ago a similar story that we've done today, but without CFX. And Dr. Ko was actually in the audience. And he basically stood up and said, bullshit. He said, we don't have anything where we can plug our machines into. I would love to see the day when I have a plug-and-play environment for my machines. Well, I don't know where Dr. Ko is today, but we did it. And Ko Young are here, actually part of the solution. So it's been great to have this company come along with us for this world's first. And then we have Hella. Hella, the CEO of Hella, is one of the co-chairs of CFX, one of the original founding members. Also a member of the Hermes committee. Again, Hella completely committed to this future of manufacturing, being able to extract data from their machines for the benefit of their customers. So we have some really great machine vendors here working together. But it doesn't stop there, of course. We have IPC. IPC actually are the sponsors or the owners of this standard. And for IPC, we see the movement forward now to creating a global digital factory. So whatever your favorite design tools or engineering tools or MES tools, etc., it doesn't matter. You can choose whatever you want. The important thing is that you've got a digital backbone of information with which to share the information between these applications. So whether it's 2581 taking data from design into manufacturing, whether it's CFX getting data from manufacturing out, traceability standard, 1782, and then feeding even the data back into design so you can do true design for manufacturing. It completes a complete digital cycle. And all of these are managed by IPC standards. So this set of digital standards for manufacturing. We are also joined by our friends at the Manufacturing Technology Centre, just down the road here in the UK. For many years, MTC have had machines in their factory so that people can come along, look at the machines, see how they work, and experience technology that otherwise would not have been available. And the people they have working there are continuing to extend the technology, create new technology for Industry 4.0 and digital manufacturing. So they are a real focus for digital manufacturing in the UK. So we are very happy to be working alongside them. This event is a kick-off event. We expect to later have more seminars with MTC and being able to drive this forward. It's not just a one-off. We will progressively work toward Industry 4.0. And of course, Aegis ourselves, we are just providing the web portal right now so people can see the data, but we also are heading toward this digital Industry 4.0. So we are very proud to be a part of this whole movement going forward for this new generation of digital MES. So before we finish, let's have a quick look at some of the activities going on. One of the main focus points is the closed loop. A lot of people talk about that. I personally saw this, so I'm happy to talk about it. This I saw in China. Now, the company in China, they set up a triple closed loop. It's like having a triple heart bypass, I guess, but you know, it's everything on one line at the same time. So from the paste inspection, they were looking at the performance of the printing, and according to any errors, they were able to make a correction. But guess what? The board had already been printed. So you then need to make a compensation for that for the pick and place. So the pick and place aligns itself to whatever the printer did. Then the AOI reads the data from the placement, knowing the offsets and corrections that have been done, and can provide a very focused comparison of what was placed against where it should have been placed. So here you have a triple closed loop. I know I've heard a lot of arguments about closed loops. Are they really effective? You know, but when you start to separate them out, when you get a clear understanding of what each machine's contribution is, they turned on the software and their defect rate went down by a factor of 10, an order of magnitude reduction. And they were making very large kind of telecoms boards. And it went by a factor of 10. They turned the software off, the defects went up. Put the software on, defects go down. Very clear. Very nice operation. The guy who developed the software, I shook his hand and said, yeah, you did a great job here. And he said, well, it looks good, and it works well on this line. But in my company, we have hundreds of production lines, and they're all with different machines. So this solution only works on one line. So I said, you need to learn about CFX here, because if these interfaces were CFX, you've finished your solution for every line in your factory, because all of the machines will talk the same language. So we made it a mission to make sure that that information was captured in CFX. So now he's in the process of modifying his bespoke interfaces into CFX interfaces, and his one piece of software will work everywhere within his organization. 10 times the improvement of quality yield. So they're going to be happy when they've implemented that. So this is closed loop, proven benefit, now digitalized within CFX and applicable to any machine anywhere in the factory. And they don't even need to talk to the machine vendors, because if the machine supports CFX, it supports their software. Simple as that. The second example, of course, is gathering data from machines for the factory. And however you break down your production time in the factory, it doesn't matter. We all have different ideas for different people with different points of view. But the data coming out of CFX is complete. It's extremely detailed. It includes all facets of information. So having some software to create your dashboards or your analytics, take the data into the cloud, Instead of putting landfill into the cloud, as most people are doing right now, just sending data without really thinking about it, CFX is added value information in a known standard, so that when you've put it into the cloud, you can actually use it, which is quite an important thing, actually. Another example is taking data from the factory back to machines. We mentioned this already about material information coming in, changing schedules, changing demands from the customer. Why can't the machines just optimize themselves? Tell them what's coming, tell them what the situation is, and let them optimize and find their most effective configuration. So maybe that means putting in common feeders, maybe it's the choice of heads or whatever. I don't know, but the machine vendors know. And if they have the information, they can further optimize their lines by using the CFX data obtained from the factory. So a kind of self-optimization. And finally then, transactional jobs. We mentioned humans having information, being guided toward different jobs. They can be doing material movements, tools, machine setup for all of these different transactional operations throughout the factory. This is kind of a great way of including people into our digital factory. I mean, eventually maybe we will all have lights out factories and all automation. But to be honest, in most cases, certainly in the foreseeable future, we need to have people included. And so being able for CFX to support all of these operations as well is essential. And of course, don't forget, CFX is not just for surface mount. For all electronic assembly, in fact, all assembly, CFX has messages in topics suitable for all of those operations. And so CFX with Hermes becomes a true business solution. So we're not just talking here about technology for the sake of it. Wouldn't it be nice? Wouldn't it make our engineers happy if? No, no, no. This is driven by business result. We want, whenever Mr. Apple knocks on our door, or whoever it's going to be a smaller company, let's face it. But whenever they knock on our door, and they're going to ask, could you? Because there are going to be many problems, of course. But one of those problems is not going to be, how smart is our factory? It's not going to be, are we able to manage our materials and know what we have in stock to be able to make anything that's required whenever they need it? It's not going to be, oh, I don't have time to make all of the new engineering programs because I don't have the visibility. It's not going to be, you know, all of those kind of setups and optimizations of machines. Because in our CFX-driven factory, all of the information is available. And we are able then to change our business according to the customer needs. This is basic common sense, actually, when I studied business anyway. So that we can be prepared. The investment, did I mention CFX is almost free? I mean, machine vendors will be providing the data, but you can just take the data. There's no $1 million price tag on this. It's reliable and sustainable because machine vendors have skin in the game. They are using CFX as well as providing CFX, and they're saving a lot of money in providing CFX. So, you know, we expect to see CFX as being very, very popular take-up amongst those. And of course, it's inclusive of people. So we're not just having visibility on one part of the operation. We can have the visibility of the whole of the operation. Okay, do we have any questions from anyone about that?